Sorry, I didn't see you there. Just practicing the new instrument I'm taking up. This is called the fue. It's the Japanese bamboo flute. I hope you're similarly exploring some different interests during this time. Most importantly, I hope you are keeping up with your work. I know Mr. Boothman is putting in quite a bit of effort to make these as entertaining, as engaging, and most importantly, as educational for you as possible. So please respect that. Put in an equal amount of effort. Okay. Let's go ahead and bring Mr. Boothman on, and we'll get started with today's lessons. Let's get started. Happy Friday. It is College Friday, so be ready to ask me any college questions you might have during our Google Meet today. A few announcements to start our day, a few more than usual. First of all, your exit ticket today, which will be due by midnight tonight, asks you to submit a picture of your completed work. I'm only asking you right now, today, to complete one of the 4 free response questions on pages 6 and 7 of your mastery sheet for 8.3. We are going to work through the first FRQ on page 7 together. So really you have 3 other options to complete. One of the 2 on page 6 or the second one on page 7. So I'm not asking you to work through all 3 of those. Just choose one, take a picture of your work, and then submit that as your exit ticket today. The other FRQs that you do not complete today are still fantastic practice as you prepare for this Unit 8 exam. Okay, that Unit 8 exam will be, I'm planning to have it next Wednesday, so we'll review Monday and Tuesday this entire unit. We are skipping the 8th page of this mastery sheet. That is what we call shell method. I've mentioned this before. It's an alternative way of finding volume of solids or revolution instead of washers. It's not really required of you, so we're going to skip over it. Additionally, as we near the end of this unit, just know there's no unit tracker here. I'm not going to worry about collecting that, okay? All right, so you have 3 options, as I just said. You can do the first FRQ on page 6, the second FRQ on page 6, or the second FRQ on page 7. Right now, together, I would like to do the first FRQ on page 7. So we're looking at this shape, y equals x squared, and y equals 4. Now, first part of this FRQ asks us to find the area of this region. Okay, so area equals, well, that's the integral. Now we need our limits of integration. It's going to be our points of intersection here. And how do we find points of intersection? We set our 2 functions equal to each other and solve for x. Take the square root, so x equals plus or minus 2. So this is the integral from -2 to 2 of top function minus bottom function. So 4 minus x squared dx. This is the only one of these 4 FRQs that is a no calculator question. So for the rest of these FRQs, so whichever one you choose to complete on your own, you may use a calculator. Okay, I'm doing the only one that's no calculator. So we need to compute all of this by hand. So we take the antiderivative of 4 minus x squared. Evaluate this from -2 to 2. All right, so this is 8 minus 8/3, plugging in 2 there, minus, plug in -2, -8, let's see, -8 plus 8/3. All right, now we distribute that negative. We get 8 plus 8 is 16, -8/3 minus 8/3 is -16/3. We need a common denominator, so this becomes 48/3 minus 16/3, which is 32/3. That is the area of this region, okay? So not too bad there. Just area of a region between curves is top function minus the integral of the top function minus the bottom function. Let's look at part B. Find the volume of the solid generated by revolving R, this region R, about the x-axis. So we're taking this region, it's coming up out of the board, it hits the board right here, where it goes back in, continues on the other side of the board, and then comes back up. Okay. Now, if we're taking a cross section, is that a solid circle or is that a washer? Well, I believe I just heard Jagger say it is a washer. That is correct. Okay. Amaya, better luck next time. So it is a washer. That means our volume is the integral from, same limits of integration, -2 to 2, of pi times, we need big R squared minus little r squared, and we're revolving about a horizontal line, which means we are integrating with respect to x. Okay, so big R. Big R is standing on our axis of revolution. Which function is furthest away? Okay, that is 4. Okay, so we have 4. And we're squaring that, so here we have 4 squared minus. Notice, since we're dealing with the x-axis, we don't have to do function minus axis here. We could, okay, but since the x-axis is the line y equals 0, we would just get the function by itself anyway. Okay. Little r is the function that's closest to the axis of revolution, in this case, x squared. So we have little r squared dx. Simplifying this just a little, we can pull the pi in front of the integral since it's just a constant. We have 16 minus x to the 4th dx. And now we're integrating this. We need an antiderivative, 16x minus 1/5 x to the 5th from -2 to 2. Plug in 2, we have 16 times 2 is 32, minus 32 over 5, minus, plug in -2, we have -32, plus 32 over 5. Okay, and I'm going to continue this over here. Pi times, all right, we have 32 plus 32, that's 64. -32 over 5 minus 32 over 5 is -64 over 5. We need a common denominator, so 64 times 5 over 5 turns into 320 over 5, which is pi times, let's see, 256 over 5. 256 pi over 5 is our answer. All right. So volume, area, pretty straightforward. Hopefully we shouldn't be having any major issues here. Let's look at the last part of this FRQ. So I'm going to erase part A and part B. There exists a number k is greater than 4, such that when r is revolved about the line y equals k, the resulting solid has the same volume as the solid in part B. Write, but do not solve, an equation involving an integral expression that can be used to find the value of k. Here's what this is saying. There's some number greater than 4, so there's some line up here, calling this k. So this is the line y equals k. There's some number for k to equal that when this region is revolved around that line, it has the exact same volume as what we just calculated, okay? The volume of this shape when revolved around the x-axis, okay? So first of all, what was that volume that we just calculated? It's 256 pi over 5. So in this case, that is our volume, that is v, and that should equal the integral from, same limits of integration, -2 to 2. Now, imagine revolving this shape around this line now. Now that's clearly still a washer, and we have pi. We need big R squared and then little r squared. Big R in this case, well, if we're on this axis of revolution, which function is furthest away? That's x squared. Okay, so we have function minus, what is this axis? We don't know what k equals, but that's okay. It's an equation that we would use to solve for k. So k can stay as it is. So this is big R. And then little r is the function closest to the axis, which is 4. Function minus axis. Dx. Write, but do not solve an equation involving an integral expression. So this is an equation. It involves this integral expression. If we wanted to solve for k, we would take this antiderivative and, we know what it should equal, so we'll evaluate and solve for k. We don't actually have to do that here. They just wanted us to set up this equation. This last part was a little trickier, just understanding what exactly it was asking of us, but we don't have to do too much work once we understand that. All right, so homework. One of the other 3 FRQs here. I want your work and picture submitted to the Google form by midnight tonight. Start reviewing this weekend. Your Unit 8 exam will be next Wednesday. Reach out to me if you have any questions. Join our Google Meet later today. Otherwise, keep up the good work. Thank you, Mr. Buchman. The rest of you, I hope you have a fantastic weekend. Join us for a Google Meet later today and ask your College Friday questions, and I'll see you all next week.